Hey guys, and welcome back to another episode of Coding with Bridges. Today, we are going to tackle down a popular problem in the world of data structure and algorithm, finding longest zigzag path available in a given binary tree. Now, what is a binary tree? A binary tree is a data structure that consists of nodes where each node can have at most two children, referred to as the left child and the right child. The first node of the tree is called the root node, and it is the only node in the tree that does not have a parent. Each node in the binary tree can have a value associated with it. The value can be of any data type, whether it can be an integer, it can be a string, whatever you like. So it can be any type of value. And such a binary trees are commonly used in a computer science for various purposes, such as searching, sorting, and representing hierarchical data. So, the structure of a binary tree is defined recursively, where each node in the tree is itself the root of a smaller binary tree. The left and the right subtrees of a node are also a binary trees and can all themselves have their own left and right subtrees. This recursive definition allows for the creation of a binary trees of arbitrary size and complexity, making them a versatile and powerful data structure. So, our problem asks us to traverse such a binary tree alternatively moving left and right, and we have to find the maximum length of such zigzag path. So what does that mean? Like, if we are going first right, then next we have to go left, then right, then again left, right, left, right, left, that way. So we will be using a recursive DFS approach to solve this problem. So what is a DFS approach? So DFS stands for depth first search, and it is an algorithm used to traverse a graph or a tree of a data structure by exploring as far as possible along with each branch before backtracking. So when we start from the root node, we will go to left. If that node is also having left or right childrens, we will go to that nodes first, and then we will be coming back to root. So this is the DFH approach. So let's dive right in and see how it's done. Before starting our coding, let's go through the problem statement so that we are sure that we are not missing anything. So we are given the root of a binary tree, that is here. It will be the root. A zigzag path for binary tree is defined as follow. Choose any node in the binary tree and a direction, right or left. If the current direction is right, move to the right child of the current node. Otherwise, move to the left child. Change the direction from left to right and from right to left. Repeat the second and third step until you can't move in the tree. So it is simple, like we can move here from right, then to left, then to right. Now we cannot go left here, so we will returning back. So this is the pretty much the problem state. So let's move to the coding side now. To start, we need two ways. Like we are having our root node in our longest zigzag function. So in on this node we have to go both ways. So it can be root dot right and root dot left. Okay, and for this nodes we want to check if it is possible to go to the left or to the right or not. So let's create a different function for that. Let's call it depth search. depth search function. Okay, what this node will have is like we will always require a node, so let's call it a root, because every subtree has a root node. And then we want a direction, let's keep it a boolean. And then we want to have a count, like until when what count we have reached till now. Okay, now this will return us an integer value, or you can say a count value, that is the maximum value available. And we want to make sure that we are calling it from the right and left value. So let's for the right value we will be having depth search. For the root node, here we will pass root dot right. Now why I'm keeping this one, because if the root node is null, then we don't want to proceed. We can also have a condition over here and check for that. If root is equal to null, which is not a possibility, then we will return 0 value. This how we don't have to check for the nullable value here. Now is it what will be the direction? So for the simplicity, let's call it like direction is equal to true. That means we are having a left direction, otherwise else right direction. So for we are going with the right direction, so we will pass false over here, and our count will initially be 0. Now let's do same for our left node, root dot left. As it is a left node, we will pass direction as a true, and at the end we will return max of this right, left and right. Okay, for the simplicity of the name, let's change the name of this direction to is left direction. Okay, now we, as our root can be a nullable value, we have to check for root is null or not. If it is a null value, then we have to return count as it is. Why? Because we have reached to an end where the now nodes are not available. If that is not the case, and if we are on the left direction, so if left direction, then we have to continue our search with the right direction. So we will go with the depth search root dot right. Now as we are going to the right direction, we will pass false in here, and we will increment our count. Okay, this is okay. Else we are going on the left direction as we are on the right direction. So let's call it depth search root dot left true, as we are going on the left direction, and count plus 1. Okay, so this will pretty much go in the left and zigzag directions. But if we look at the example number 1, here our root is only having a right node, and that right node is further having a left or a right node. So it is not possible if we count from the first root, and if we do that we only have a zigzag of 2. But if we count from the first node of first right node, then we can have a longer zigzag path. So to achieve that, what we have to do is we again have to go here with the different direction. So max of we will keep, again we will call depth search. Now instead of going to the left, we are here going to the right direction. We will pass false as we are going to the right direction. Now what about the count? As we are changing our directions here, like we are not changing the actual direction that is told, but we are finding a new way of getting a maximum zigzag possible. So here we will initialize our count as a 0 as we are going with a new search. Similarly, we have to do that for the left direction also. So here we will write max of, and again add a depth search with root dot left. We will pass true over here and count as a 0. So that will cover all of our cases. Now let's execute this and check with the test cases. We got a compilation error here. Let me check. Okay, it's a typo. It's a depth search. Sorry for that. And our test cases are accepted. I hope you guys have enjoyed this video, and please do like and subscribe to my channel, and have a good day.